for our last example in this section, again, we're going to find the area between these two curves, between these two graphs. But notice the directions. It says integrate with respect to y. Usually we are integrating with respect to x using dx. This time they want you to integrate with respect to y, so we have to use dy. What that means is that we're going to want to solve each of these equations. Instead of solving for y, we're going to solve for x. Well, this first one is ready to go. I'm just going to kind of circle that. But you see that the second equation, I'm going to have to solve it for x. So I will. I'm going to subtract 2. That's going to give me y squared minus 2 is equal to x. Now I have that one solved for x. I'm going to rewrite that one. I like to always put it with my x first. So that's going to be x equals y squared minus 2. And that one is now ready to take a look at. Let's find out where these intersect. This time we're setting the x's equal. So y plus 4 is going to be equal to this x, y squared minus 2. Set to 0. I'm going to subtract y. And I'm also going to subtract the 4. So negative 2 and then minus 4 is going to give me a minus 6. Got this set to 0. Factor. That's y minus 3 and y plus 2. So that gives us our limits of integration, but these are y values this time. So y equals positive 3, y equals negative 2. Those are going to be the limits of integration that we're going to use. The next thing we want to do is to find out which one, instead of saying top minus bottom, we're going to really think of it as right minus left. Or just think of it as always big minus little. I want to find out which one is the bigger one. Graphically, it would be the one that's further to the right, but we're just trying to find the bigger one. I'm going to pop in a y value between negative 2 and positive 3. Again, 0 is a good choice. It's pretty easy to pop in. So if I plug in a 0, I'm going to get 0 plus 4 for this one. My x value is 4. And for the second one, if I pop in a 0 for my y, I have x equals 0 squared minus 2, or x is negative 2. So definitely this one is the larger one. That's the one that's going to be further to the right, the one that gave us the positive 4. So I'll put that that's our big one. And over here, this is the small or the little. And now we know which one's going to go first. It's always going to be big minus little. So we're going from negative 2 to positive 3. Those are our limits of integration. Negative 2 to positive 3. The larger one is y plus 4 minus the smaller one is the y squared minus 2. And we're taking this integral in terms of y with respect to y, so dy. Let's distribute. That'll give me negative y squared of plus y. And then 4, this will be a plus 2, is 6 dy. Now we can integrate. That's negative y cubed over 3 plus y squared over 2 plus 6y. And we're taking that from negative 2 to positive 3. Now we can just plug in our 3. So negative, this is going to be 3 cubed over 3, plus, plug in your 3, 3 squared over 2 plus 6 times 3 for y minus, and now we're going to plug in our negative 2 carefully. So negative and then negative 2 cubed over 3 plus negative 2 squared over 2 and then plus 6 times that negative 2. Start to use our calculator now. This ends up being a negative 9 plus 9/2 plus 18 for the first part. Negative 2 cubed is negative 8. This is going to end up being a positive 8/3 here. Plus, that's 4 over 2, which is just 2. And then 6 times negative 2 is going to be a minus 12. Let's make sure we've got all of that right. And then pop it into your calculators. I'm going to get 125 over 6. So again here, the trick, if you have to integrate with respect to y, and they're asking you to do that, don't solve for y, solve for x, and then you can find those values. When you solve for x, you're going to find out what the y values where they intersect, and just do big minus little always. And for this one, it's really the right minus the left. But if you always put big first and little second, you're good. And a hint, if you go backwards, if you accidentally put the wrong one first, your answer will come out negative. Area is between these curves is always going to be positive, so that's one way you can kind of check your work just in case. Always you should get a positive answer for your area between two graphs.